Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 98. Validate binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree. Okay, what are the conditions of the valid binary search tree? The whole left subtree node should contain only node with keys less than the node's key. And whole right subtree of a node contains only nodes with keys greater than the node's key. Both the left and the right subtree must also be binary search tree. Okay, they are asking us to find the valid binary search tree, and they have given the condition for the binary search tree clearly. Okay, let us understand first. Let us take this example. Okay, let us take this example. Now, tell me in this example, whether this first example is a valid binary search tree. Yes, I can say it is a valid binary search tree. But you may ask, but how we are telling it? Okay, let me demonstrate. First, we are standing here, right? Okay, I'm going to see for this node, every left subtree value is less than 5. Yes. Every right subtree value is greater than 5. Yes. Okay. Move on to the next. Okay. Now I'm going to see whether for this one, whether all left subtree values are less than 1, all right subtree values are greater than 1. But unfortunately, we are nothing, right? So we don't do anything. Okay. Now for this 6 again, I want to check whether all right subtree values are greater than 6. Yes, all left subtree values should be less than 6, but there is no left subtree. So don't worry. For this 9 also, there is no left and no right. So leave it. Don't leave it. So I can say for all node, this condition satisfied. So I will return what? I return true. Okay, hold on. Let us see another example so that it will be more clear. For this example, I can say for this 5. For the left subtree, it is okay. But for the right subtree, we have what? We have a 4. But 4 is greater than 5. No, right? So we want to return what? False. Hope you understand. So, telling for this example, for 5, the left and right are valid. For 2, there is nothing. And for the 7, both left and right are valid. For the 6 and 8 also, there is nothing. So leave it. So I can say for this, it is true. Can you understand this? Yes. So, what is the brute force approach? Brute force approach is something I done here. What? Just take each and every node and go to the subtree of them. Just go to the subtree of them. For example, take this 5 and go to the subtree of them and check whether subtree are less than and greater. Which means what? The left subtree is less than and the all right subtree values are greater than. If it is so, just return this proof for this 5 alone. And then go and check for this 2. And then go and check for the 7 and go and check for the 6 and 8. If all are true, just return it. Can you understand this? So this is my brute force approach. So once my time complexity, it is O n square because we are just standing in one node and just searching for entire descendant. Right? Which means what? Entire left subtree and right subtree. So it will be n square and space constraint will be what? We are doing what? DFS traversal. So I space constraint will be something like where touch is the right of this binary search tree. Yes. Okay. Now, tell me whether it is necessary to go from one to take each and every node and go to the left and right subtree, then take this node, go to the left and right subtree, then take this node, go to the left and right subtree. Whether it is necessary. Okay. Let me tell you something. See here, the 6 and this 8 subtree is also subtree for the 7, right? Okay. The 2 and 7 subtree is also subtree of this 5, right? So instead of going from top to down, we can go from bottom to up. Yes. Okay. But how? You may ask for how? Okay. So what is the something some logic behind? Okay, let us think about it. See here, if it is 5, then all right subtree should be what? Should be greater than 5, right? And here it is be less than 5. So I can say this 5 can be anything from int min to int max, right? This can be anything from int min to int max. Okay. Then what should be this left subtree values? So I can say this left subtree value should be something like int min. You can from int min, but your uppermost range is what? 5. And for our right subtree also, it can be anything like from 5 to int max. For each and every node, if we put this range, it is so simple, right? Okay, let me demonstrate it. First of all, let us see for the true condition, then we can see for the false condition. Okay. So what is my approach? I'm standing here. Okay. So this can be where? This can be from int min to int max. Okay. Initially it will be int min to int max, the range. Okay. Now 5 is in this range. Yes. So don't do anything. Just go. Okay, I'm going here. Whether this 2, what is the range for this 2? I can say it will be something like you can go from anything up to the int min, but your at the most range will be what? At the most it will be 5. Okay, isn't it what? We can go up to 4. Okay, hold on. Whether it is in this range? Yes. So don't worry, go down. Okay, while going down, what will be in the range? It will be something like int min, but your utmost value should be only 2. Yes, but it is null. Okay, go back. Okay, now we going right side. What should I look at? I should look at what is the utmost value. Okay, utmost value is 5. Okay, utmost value is 5. But what is the least value I can have? The least value that I can have is 2. That means what? The current value should be greater than 2. Okay, greater than 2 and less than 5. Okay, now it is also not. Okay, just return. Okay, now just return. So while returning, it will be returning what? A true. Here also true. Because here also true, right? Yes? Okay. Now I will go to the right side. While going to the right side, what should I take care? I should take care like, okay, the minimum should be updated to 5 while the maximum will be remain same. Can you understand this? Why? The all subtree value should be greater than 5, right? That's why. And now, while going to the left side, what is my range? Tell me, my range something will be 5 to 7. Yes, okay, it is valid. Yes, then I will go to the left side. While going to the left side, what is my range? It will be something like, you can have anything that is less than 6, right? But it should be greater than 5. So it is null, so it returns what? True. Here also it goes. What is the range? The range will be anything above 5, anything that is below 6 and, below 7 and greater than 6, right? Okay, here also null, so return. Okay, now this 6 returns what? True. Okay, now go to this 8. For this 8, what will be my range? My range is something like, you can have above 7 up to max, up to int max. Okay, now this 8 is in this range. Yes, so don't worry, this just go here, it will be null. Here also null, so return true. Just return true. Okay, here also is return true, and here also return. Fine. Now let us demonstrate by using the second example. Okay, just see here, I am here, right? So what is my value? It will be something like min to max. Okay, whether it is in this range? Yes. Okay, go to the left side. While going to the left side, what should I update? I should update like, we can have anything minimum, but up to range of what? Up to range of 5. Whether it is in this range? Yes. Okay, go here, it will be null. Okay, backtrack with true. Here also go here, it will be null. Okay, backtrack with true. Okay, now again, what should I return here? I should return true, because both are true, right? Okay, now I'm going to the right side. When going to the right side, what should I focus on? I should focus on the maximum, right? So minimum should be minimum only. Sorry. Minimum should be 5 only, but maximum will be at the maximum only. Can you understand this? It should be greater than 5, but maximum should be not same. Okay, now for the 6, again I will go to the left side. While going to the left side, what should I taken care of? I should take care of 5, 6. Right? But whether this 4 is in this 5, 6, no, right? So I have written what? A false here. Okay, 6 goes here. Here also null. So it returns what? A true here. Now comes it to see here. False and a true. What should I return? I should return a false. Okay, here true, here this false. So I should return what? A false. So at last, what is my answer? It will be false. Can you understand this? So what we are done here? We are taking a range. What is the range? For left subtree. What's the range? For left subtree, see here, minimum is not updated. Only the root value is updated, right? So take the minimum as it is. But only change the maximum as root value. For the right subtree, there is no change in what? No change in maximum. But change what? Root value as a minimum. So this is the relationship between the left and right subtree. At last, just return what? Just return what is the return value of the left subtree and what is the return value of the right subtree. And what is our base case? Base case is something like, if our root the current root is equal to null, then what should I do? I just return true, right? And also we will include some condition like if the current value is not in a range, if the root's value is not in range, then what should I do? I just return what? A false. That's it. Simple, right? So these are the few lines of code to do this step. Okay, what's the time constant in space constant? That's the important thing, right? Okay, tell me what's the time constant? I can say time constant will be O of n because I'm just passing each and every node only one time. And also space constant will be what? O of pets. So this is the diamond space constant analysis. So why O of it? Because we are doing a DFS traversal. In this DFS traversal, we will take a recursive stack. In this recursive stack, it will be storing what? The height of this binary tree. Right? That's it. Let us see the code. While seeing the code, I will tell you the wrong approach also. See here, this is the wrong approach I done at first. See here, what I done here. If root right and the root value is greater than or equal to root.right.value, which means what? I'm just checking the root and left and right. I'm not checking the left subtree, entire left subtree and entire right subtree. I done this mistake. Okay? If that the children and the node is not in a correct BST condition, then I will return false. But that's not right. We don't want to check the child alone. We want to check an entire binary tree. Sorry, entire the subtree. Right? So that's what I have done here. Okay, so this is the wrong method. Okay, then what's the right method? See here, def DFS of root. I take on the root, then start, then the end. So 3 parameters. Now, if not root, then what I do? I just return true. If root's value is less than or equal to start, or root's value is greater than or equal to end, which is what? It is not in the range. It is not in the range. Then I should return false. Okay. If I am going to the left subtree, my start will be limit start. My minimum will be minimum only. But my maximum will be updated as what? Root's value. And I am putting what? And operator here. And then is what? If both are true only, it returns true. Okay. Now DFS of root.right, root.val, end. I am just updating what? My minimum. Because all right subtrees should have what? Greater than the current root value. Right? And then I'm just returning by calling the DFS, this DFS function by using what? Minus infinity to plus infinity. This is what? Into min to into max. Let me submit it. Yes, it is submitted. Thank you.
And the other hand, dad.